Hello, everybody, and welcome again to another session, another Scaleway session, another session of the Scaleway sessions. You know
Keep
when you
saying
say a
it.
word
Yeah.
over and over again, it starts to
hmm
sound weird?
It's not a
Anyway,
word anymore.
Scaleway or session.
yes. So, welcome, everybody, to another session, another edition, another one of these that we do every week. Thank you so much to everybody that's been coming out regularly, that's telling your friends, and they're joining on the stream, and that's been super fun. Thanks to everybody, of course, that sends us messages on the socials, that's contacting us on the Twitters, that's reaching out to us on the community Slack. Super fun to get your feedback about these sessions, to hear that you're working on stuff, that maybe we solved a problem or created a problem. Either way, I'm happy. So today we've actually got something a little different. We've been talking a lot about Kubernetes and whatnot over the past month. Everybody loves Kubernetes. We will probably use that word again today at some point. It's fine. But we actually have a special guest. First time on the stream, hopefully not the last, but we'll see how it goes. Uh, would you like to introduce yourself, Martin?
Yes. So my name's Martin Thwaites. I go by martin.net on the interwebs everywhere, from Twitter to Mastodon. So follow me there if you want to. I'm a principal developer advocate at a company called Honeycomb. We do observability in general. We have a platform, that kind of stuff, and I'm one of the dev roles. I go around the world talking about this stuff. So that's why I'm here, I suppose.
Well, and also because on the first stream we did, I posted about it on Twitter and you DM'd me being like, so where's my invite? When am I coming on this stream? So here you are.
I may be a little bit addicted to audiences. I'm sorry.
Aren't we all? It is the job that we've all chosen to do. So thank you, Martin, for the hellos. In case this is your first time joining the stream, or maybe you haven't joined in a little while, my name is Dan. I'm the head of developer relations at Scaleway. Uh, I continue to be the head of developer relations at Scaleway, so that's nice news for me. I'm joined, as always, by two other members of our developer relations team. Eli.
Hello, I'm Eli. I'm one of the developer advocates at Scaleway. And I know Martin through conferencing, through various meetups, having found myself in the .NET world despite never having written a line of any .NET language. So having an excuse to drag him on stream is very good for me. Get to hang out with him for now.
Cool.
Diego.
Diego, I'm the other developer advocate here at Scaleway. And fun fact, one of my first pieces of code that worked was on Visual Basic, actually, which I didn't touch ever again after that.
And you're not alone. I don't think anybody's touched it ever since. I like the distinction there about the first line of code that worked.
Oh, yeah.
You wrote loads of Java and stuff like that. None of that worked, but the VB stuff did.
For
I think my
some
first
reason,
coding was like CSS. I wrote my own Tumblr theme back in the day when I was like 18 or something.
So are we considering
MySpace.
the front page apps and the Dreamweaver attempts? Because if that's the case, then yeah, front page
Oh yeah,
was
I would
my
have
first
written.
thing for creating HTML.
Yeah, I would have written HTML actually before that. Yeah.
I mean, I remember writing the CSS themes for MySpace, where you could drop those in your header and you could, make it rain and put balloons up and stuff like that.
The little effects that follow your cursor.
Yep.
Oh,
Yeah.
yeah.
Oh my
Oh,
gosh.
yeah.
That doesn't exist anymore on the internet. It's sad. Like just little places where you can do that kind of thing. Like
I mean, it's
free
almost
webs.
like that might have been, maybe a security vulnerability, maybe.
Well, when you think about it, a web browser is kind of a rough idea, right? Like, let's absolutely run completely random, unsigned code on localhost.
Yep.
Yeah.
And now we have WebAssembly.
Yes.
Do even more weird and wonderful things.
Yeah. Well, let's take a perfectly good markup language and then rub executables on top of it. That sounds that sounds like a recipe for hilarity.
Yeah.
So,
An interesting thing that's actually happening in the .NET space at the moment. They're writing a kind of containery type thing that allows you to run WASI code inside of .NET assemblies, so that you can have complete like V8 isolates for JavaScript to just run that in a little container. and allow unsafe code to run inside your .NET application that other people provide you with. And it's one of those, why did you do that? Well, we could. Doesn't mean that you should.
Has anyone, paging in cold water, has anyone, told them that this is happening? I feel like this is ripe for somebody just breaking it horribly, right?
Oh, yeah. I mean, there is a big note on the repo that says, there has been no security analysis of this. Do not trust it.
Don't do it. Don't do it.
It reminds me of a presentation I once gave where the first draft of the slides had a big one that just said in the biggest writing that would fit on the slide, "Don't do this." And I can't remember now what it was about, but
So interestingly, I did a presentation recently for a front-end conference, and I did the thing where you submit an abstract well before the time around observability, and I'm like, well, it's front-end, I'm .NET, obviously it's going to be about Blazor, so great, and OpenTelemetry, and I'll do a talk around how to implement OpenTelemetry in Blazor. Got accepted, great. About 3-4 weeks before, let's build the demos and the presentation. Oh, this doesn't work. Oh, that's interesting. So my entire presentation, first slide was how to implement OpenTelemetry in Blazor, and the second slide was 7 ways not to implement OpenTelemetry in Blazor.
I bet it was a great talk though.
So yes, I am familiar with the "it doesn't work" things.
Why doesn't it work? I mean, in fact, you want to tell us what OpenTelemetry even is, as
Start
somebody
right
I think
there,
covers in
yeah.
experts.
It's a nice segue. It's almost like that was planned. So OpenTelemetry is around the idea of how do we achieve visibility in our applications? The wider term for that being observability. So how do we get the ability to observe our applications in production? Now, for many, many years, we had APM tools that would sit alongside our applications, would reach inside, grab a load of analytics out, and then provide some pretty graphs for the management team to say, yes, you're doing things great. Over time, that kind of stuff has become a little bit harder. So when we moved into distributed systems, you've obviously been talking quite a lot about the K word that shall not be mentioned. But the idea of distributed systems means that we no longer have this ability to just drop an APM tool on one service and then view that entire thing. That's just not possible anymore. So when you start to work in a polyglot way, where you've got lots of different services in lots of different languages, you end up with this idea of, well, I've got multiple agents and they all need to communicate together. So OpenTelemetry was founded by 2 different projects, OpenTracing and OpenCensus, about 7 years ago, I think it was. And what happened was you had all of these different applications, different languages, and how do we show a request that transitions through multiple different microservices or even just normal services? Because, well, this application needs to know about the context of this application, and it sends it over and goes, here's all my context, and this other one goes, well, I'm in PHP. I don't know what your .NET context looks like. So OpenTelemetry was this idea of how do we bring all of these things together and make it so that from an application perspective, you don't need to care. So OpenTelemetry is a couple of things. At its heart, it's a protocol, which is how do applications send telemetry data to backends like Honeycomb or Jaeger, all of those kind of systems, in a standardized way, so that in our applications, we always have the same outputs. But it also provides SDKs that you can implement in your language that allow a transition of context between the two. So a trace, which is one of the core components of OpenTelemetry, is this idea of a causal graph of I did a HTTP request, that caused a database request to happen, that called it to call this other service, that other service caused a database request, etc., and down this big tree of a trace. So OpenTelemetry was kind of this whole thing around how do we bring all of those things together and just make it standard. And it is, at the moment, the number 2 project from the Cloud Native Compute Foundation. Number 2. It will be number 1, above that K-word thing. Was it 2.5 days, something like that? which one of my ex-staff from a previous company used to call it Kubernetes, and it was hilarious. I told him a few times it wasn't called Kubernetes; it's pronounced Kubernetes, or Kubernetes. It's another one I've heard.
We didn't consider this. We've had a running bit about words that we can't decide the pronunciation of in this space, and obviously like kube control, kube cuddle, kubectl, blah blah. Never considered Kubernetes itself actually as a candidate. Yeah.
But I like Kubernetes. I think that's the high end, like paid for professional version that's really expensive and reserved for those. Really
you worked a bit of enterprise on it.
Yeah. It's like, oh no, we don't use Kubernetes. We use Kubernetes.
Make it sound kind of Latin. I guess you've just taken it from Latin, Greek into Latin, right? Kubernetes.
Yeah.
Thinking about tracing, I remember my first job out of university working for a telecoms company on a session border controller made up of lots of these different components all written in C. And the in-house tracing tool we had for that was incomprehensible. Just you'd get the traces out and you'd spend half a day going, okay, what does this arrow mean?
Yeah.
That sounds about right. I mean, so I spent a number of years working for another observability company that you may have heard of called Datadog, and seen sort of the transition. Yeah, it's another. I don't know. It's got a dog and it's holding a graph in its mouth or something. Anyway, to see the transition kind of going from when I first started system administration work back in the and the tooling that was available then, like version 1 of Nagios or Nagios, GIF, whatever, and they added like the ability to turn the numbers into like little dots that were colored, and it just like
I thought you were going to say, oh, they introduced color. Yeah,
I could like look at a board and like, look, it's yellow, look, it's red, and all of a sudden you just look at a thing and go, if it's all red, then obviously something's on fire, and if it's all green, then nothing's on fire. Let's go have beers. And to go from that to the tooling that we have now, right, where if it's all green, we can go have beers, and if it's all red, something's on fire. Wait a minute.
Humans like those systems. We're just that's great. We crave simplicity.
Well, one of the things I talk about quite a lot. So when we talk about tracing and stuff like that, tracing isn't hard. It's a causality graph. It shows a line at the top and then things that go down. It's not exactly complicated. What is complicated is finding the right trace. So finding the problematic traces and going into the system to find them. And as humans, we're really good at pattern matching. So if we see an image, we can see where an anomaly is. If you show me an image, I'll tell you what doesn't look right. You'll see a sea of data and then some things up at the top. Oh, those are obviously the wrong ones. But we're not really good at trunking through 4 million rows and finding out where the things are that are wrong. And I think that is where the value add comes in from a observability sense. Like, how do we give that to people to say, go and find the right trace? That is really awesome stuff that I think that's what the tools are giving now that they didn't back then. They give you a line graph, great. But that's what these back-end tools are giving now. That's their value add, is finding the right data. Not just looking at a thing, because anybody can look at a correlation, find a correlation ID, and then look at all the logs from those things. Representing that data in a graphical way, that is what I think we've come on quite a lot since the Nagios days. And I call it Nagios, by the way. And
I call it Nagios. The G is like in Spanish, so just to make everyone angry. But so we were talking about graphs, and this is actually another subject that's come up a couple of times recently on stream. This idea of graphs. We talk about GraphQL, but we talk about graphs in general. It's just math at the end of the day, right? And this idea of having acyclic graphs and directional acyclic graphs, and so on and so forth. But these sort of models, these mental models we have of representing the relationships between pieces of information that would not normally be relatable, right? Is kind of what we're talking about here. We're saying that we have this fairly complex Rube Goldberg style machine, upon which our entire business is based. And over in some corner, right, on an ephemeral container or some sort of serverless function that runs for half a second, something happened. And then a butterfly flaps its wings, right? And 30 minutes later, the Redis queue is falling over. Right? And having now even back in the battle days, we had the ability to see like something happened over there and something happened over there, but that it was figuring out that this was related to that. That's the magic that we're getting now.
Yeah.
Right.
We were talking about this idea of the matrix, and you've got the big ops center in organizations, and they have 72 400-inch monitors across an entire football field of wall with tons of graphs and tons of metrics, and some of them go up, some of them go down, some of them are sawtooth. And you get somebody new into those organizations and they'll look at the screen and go, I don't know, is up good or is up bad? I don't know. But what you do get is the people who've been there for, say, 10, 15 years, they'll be looking at this sea of metrics and graphs. And what'll happen is they'll go, there's something wrong over here. And you're like, how?
They've perceived they've perceived something in this sort of beyond the ken of us mere mortals.
If you are lucky, they'll be able to say that graph went up and this one went down. If you're very unlucky, they'll just go, it doesn't look right.
I sense a disturbance in the force.
And it's
that happens.
Matrix,
that happens all the time too, right? I remember another story from the past. At Mozilla, we released the Firefox web browser. This was before Chrome existed. What a golden era. And every once in a while, despite all of our best tests and despite all of our beta programs and alpha programs and good developers and blah blah blah, it turns out that very occasionally you release a bug into production. That happens.
No.
Yeah, I know. I know it happens. It happens. And I know. So if you're like there's like we have a web app or some sort of thing that people touch online or whatever, and you release it and it's in production and it's like, oh, we found a bug, then no problem. Just trigger the CI/CD pipeline, fix the bug, and it'll go out. But a web browser, 10 years ago, when that went out into production, that was out in production. Like people are running that on their computers now, So we tried to avoid that, and what it did very occasionally happen, it was what we call a chem spill, right? Sort of the worst thing you think of, like, oh my God, some sort of contagion has entered into the wild, and we need to, we need to put on the hazmat suit and rein it in.
I hate you using that as a metaphor when we're having like continuous train derailments in the US with chemical current affairs. But current affairs.
Yeah. Well, I don't think any of us happen to be in the United States, so that's that's over there. We're talking about what's happening over here, and so what's happening over here is chem spills. So we have to try to contain this, but first we'd have to realize that it happened, because obviously none of us saw it, none of the alpha and beta teams saw it, none of the tests saw it. So how did we even know it happened? Right? And it was exactly this. It was literally one person who lives in Australia who was just so in tune with the graphs that he would look at the telemetry data and just be like, nope.
There's a disturbance in the force.
Exactly. Like, that doesn't look right. Right? I would just be like, and all of a sudden it'd be all hands on deck, because everybody knew if he's the guy, his name Glob. So if Glob said, nope, the entire worldwide organization was mobilized.
I hope that guy got paid the big bucks.
One must assume. A very dangerous single point of failure, though. One dude in regional Australia does not an end-to-end testing system make.
I mean, one of the things that we've been talking about a lot recently is the idea of P99s. And a lot of people use P99. So P99 being the idea of what are 99% of our users seeing, because we don't care about 1% of our users. Nobody says the second part, but that's what they're actually saying. And that idea that you're looking at these graphs and the change is so subtle, it might only be 1%, but it might only be 1% now. It might be 1% now, but then 2% tomorrow, 3% the day after, and eventually it starts coming into those. And what you end up with is these people who are attuned to that 1%, and they know what that 1% means. And I think over time, we've, as a industry, especially from like the Nagios days where storage was expensive. Like storing data was really, really expensive. Oh, I need more hard disks. I'll order some from Dell and they'll be here in 4 weeks. And then I'll have to go to the data center and I'll put the storage into the machine and I'll format it and then I'll expand my array. Like, no, I'll put it in S3 and it'll just, or I'll put it in, somewhere that just expands automatically because I don't have to pay for, I don't have to provision it. And we've come to this world now where we used to use metrics for that sort of stuff. We used to use metrics because they were easy to store and they were cheap to store. We'd use, back in the day, I don't know whether anybody else remembers the RRD tools, way, way back. So RRD being the idea that you'd store something like every second worth of data for the last hour, every minute worth of data for the last day.
Mm-hmm.
Yes, Cacti, yes, absolutely. But that you couldn't look at a 5-minute period from last month. You couldn't look at that because you'd only store the days for the last month because storage was really expensive. Nowadays, it's not. And we've got much, much better tools to be able to retain context and be able to do all of that data. And data is now cheap. Storage is redonkulously cheap.
I mean, by comparison, let's be clear. It's cheap by comparison, but everything is a question of scale, right? I mean, we talk about S3, global object storage systems come in many shapes and sizes, and you can kind of get super commodified, right? And so, the invisible hand of the market has spoken, and this is how much it costs to store arbitrary units of data in arbitrary places, right? But it's not zero. To be clear.
So I've been looking at I'm building at the moment a proxy for OpenTelemetry using .NET, just as a thought exercise to see what we can do with it and to understand something called tail-based sampling, which I'm sure we will talk about today. But one of the things I was trying to do was say, take all of the span data and store it temporarily somewhere. And I took a unnamed popular cloud provider that provides really simple storage solutions and looked at exactly how much it would cost to store at scale some of their stuff. It turned out it was $1.5 billion per month if we'd have gone away with that solution. So we're not doing that one. So yes, relatively speaking, at certain scales, yes, it is cheap.
It does mean, though, that now it's cheaper than it has been relatively. It's much more feasible for, the person who's looking at all of these graphs and lines, line go up or line go down and go, oh, something's wrong there. I know this because it happened 2 months ago and this was why. That somebody could actually go look at the context from that 2 months ago. Whereas if you were using the thing where you'd only store daily data or you didn't have the context, that would be lost and only live in that one person's head.
Yeah. And that's the rub with observability really is how do you democratize that ability for the rest of your teams to be able to ask these questions and also work out what you asked if you're that person, that when you've got that SRE that's been doing this a while. So the example I use is that the SRE, that she's called Laura, she's absolutely amazing and she solves this problem. And she solved it last night. And I want to know, how did Laura find that? because we all, in that sort of time frame, we write down every single query that we wrote, and at 2 a.m. while we're bleary-eyed trying to fix a bug, we write down all the query paths and how all of the investigations we did, don't we? Yeah, because we're all that diligent. No, nobody is. But what we want is for everybody to be able to learn from Laura, because that's the person who knows how to do these things.
And presumably she needs time off at some point.
Apparently, yeah. I mean, so we want to be able to make sure that everybody can do these things, and that I think is where people struggle, because people don't put observability first; they put observability last. Observability is the thing you add at the end, and it's like, oh yeah, we're ready to go live. Have you added any graphs to see whether it's working? Like, maybe we should do that before we go live. No, maybe you should do that when you start developing. Like, that's where you should be doing this stuff, so that you can be educated through the entire cycle, so that everybody knows what's going on. It's part of what you've been doing every day, not just the thing that you add at the end. It's one of my major annoyances with boot camps and that kind of stuff is module 11 out of 12 is the observability module.
If it's even in there, man. Honestly, if it's even in there.
Because otherwise what you end up with is you've built something, and the only person who can debug it is the person who built it, because it's their baby and it lives in their head and they know everything about it.
They probably can't even debug it. Come on now. I mean, software, especially at a certain level, is extremely complicated and extremely complex. And like, who amongst us? Who English?
Among Us is actually trademarked, so.
Oh, okay, all right, there you go.
DMA for that.
So whomst amongst us has not written some software, put it away, come back 6 months later, and gone, well, I need to start from scratch because none of this makes sense to me.
I diligently comment my code, so I don't know. I have no idea if this experience is great. I've done that so many times.
I just write code that makes sense. But I mean,
it's self-documenting, is it, Martin? Oh,
this is the trick to being good at, being a good software engineer. Is just be good at it. Just do good work.
Yeah.
I love seeing like X plus Y, and then the comment is add X to Y. Be like,
oh, I love the ones where you've got an ID property, and people have used like XML doc stuff, and they've added XML doc, and it says the ID of the entity. Like, I'm pretty sure I knew that. Like,
we're good.
My favorite comment I've ever seen in a bit of code was a couple of jobs ago, data engineering, and there was some janky piece of the pipeline, right, that we had to take data from proprietary format and convert it into something else that was actually usable. And one bit was like, if we don't have this piece of data, set the value of this column to -1. And there's a whole debate chain in this comment thread about whether or not it should be 0 or -1. And it says, ends with citing an email between two people whose initials are given, both of whom left the company 3 years before I started.
I mean, my favorite is the one where it says, lots of people have tried to optimize this bit of code. It is as optimal as it will get. Please increment this number once you've tried it.
Oh yeah, add here the number of hours, increment the number of hours you've spent as a warning.
Mine is first line of code. Sorry about this.
Let me preface this with a sincere apology for what you're about to see. Yeah.
There was, at least a couple of years ago, it could be gone now. Last time I looked, I was rummaging through the default datetime library that comes with the Python programming language, because this is a sort of thing I do for fun. And there were entire chunks in there where the comment blocks were, in some cases, pages long for 1 or 2 lines of code, because they're explaining these really intricate, this handles an extremely specific edge case, et cetera, et cetera, et cetera. And they're just like, look, don't touch this. Just don't. just don't do it. We will not accept any pull requests. Nobody here that's still working on this understands how it works. Do not touch this.
Unless the international dateline moves, this is it. This is how it is.
Which, by the way, happens. hence these weird little bits of code, right? Yeah.
Oh, I have a friend who's really into the esoterics of languages and like as in spoken languages and written languages, and did a whole rant on time zones. And apparently, I believe it's Sweden had this period where they were changing their calendars, and they did a slow rollout over 40 years. And they got 10 years in and the king changed and then canned the whole project. Like, if that's not an analogy to big waterfall projects, I have no idea.
That's delightful. Yeah. My spouse is also a big linguistics nerd as well, so I'm gonna have to go and ask them if they've heard this story because that's hilarious.
So I don't want to make this entire stream about time zones because I absolutely could. By the way, but these edge cases absolutely do come up, and they come up in weird ways that are super unpredictable, right? Really, just recently, in the case of I think it was Lebanon, you had one population in the country that decided that they were going to change the clocks according to a pre-established international, daylight saving time thing, and another group in the country that decided no, actually, we're going to wait. And now, then for a period of time, for a couple of weeks, depending on which group you were in the country, it was a different time of day.
I worked with somebody, or worked in the same office as somebody who did that, name of Malachi, and it was just like, okay, this meeting will be at 3 p.m. That's 2 p.m. Malachi time.
Right.
Because he just refused to do daylight savings.
So to transition back to the subject at hand, right?
Again,
Which is when you have these situations that pop up where you have, okay, like I have code and I have things that are running and there's CPUs. And sometimes stuff happens you don't expect, these sorts of emergent properties that come out of systems, especially large systems, distributed systems, which if we're all doing functional programming and we're using monads, we don't have this. Okay, fine. But
about that.
yeah, but we're not all doing that, and it's not even a real thing anyway. But we're not all doing that, right? And so you have these errant behaviors, these emergent behaviors. The world of observability is a way to help us see those things, right? To help us understand those things. But that first part is important. Just knowing they're happening at all, right, is pretty clutch. So if I can get you, Martin, just indulge me here, right, to sort of walk me through kind of what would that debugging process feel like? Like if you had, you had a distributed system and you had some reasonable observability tooling available to you, and someone walks into your office and just goes, I don't know, the website's slow.
So this is, I always say there is more art than science when it comes to observability. It's not, and this is the reason why I don't think APM tools work in the current model of what we're developing, because there isn't I just add a thing and all systems are the same, therefore all graphs can be auto-generated and everybody has the same graphs. Everybody has the same level of logging or tracing. As long as you've got these things, we can debug everything. It just doesn't happen anymore. What I can say, probably turning that around to give you an answer rather than it depends, have been a consultant for way too many years. But to give you an actual answer, the real answer around debugging is, yes, somebody says it's slow. How many users is it slow for? Because if it's slow for 50% of the users, you're going to see it no matter what tool you use. You're going to see big spikes, you're going to see big dips, you're going to see an escalation curve. You're going to get when I was working for Manchester Airport Group, I had the best signal for things going wrong ever because we were based on campus and we were doing the car parks. So there was actually an audible signal of cars beeping when they couldn't get into the car park. And once it got to us, it was really bad because we were quite far away. So if it was backed up to us and people were beeping, we knew there was a real problem. So if it is that bad, then yes, you are going to see it no matter what you do. The problem nowadays, though, is it's subtle. It's the 1% of users are seeing problems. And it's that 1% of users that are the ones that They're in Norway. They're using the French language pack on their phone, and they're accessing it on iOS 14.1 and 15's out. It's that intersection of things that are now the problem. Because if it's affecting everybody, it's obvious. It's when it's affecting a minority that it's hard. So, yes, if there's a problem, it's going to be easy if it's all of them. Just look at your metrics and it'll tell you it's this one endpoint, fine. Or it's the whole site. Or you'll look at the CPU and all the CPUs are going wild.
Yeah, you can have like one of these marching ant graphs, and this one over here is red and angry. Well, there it is.
Yeah.
Yeah.
What you don't see, though, is the subtle ones. And this is where we were talking about that big metrics dashboard where this one just goes up a little bit and that one just goes up a little bit and then this one goes up a little bit. And there's going to be a real problem tomorrow. Or, yes, this is affecting the CEO. This is one of my favorite things to do when we talk about things like tail sampling, because we want to see those really small problems that only happen to a subset of users, and we want all of the context. And with tail sampling, one of the really cool things you can do is work out whether the user ID is your CEO, and if it is, then you keep all of their traces. Because nobody wants to be saying to the CEO, "I'm sorry, I don't have your data. We sampled that out." So when it's a subtle problem, those are the harder ones. And when you get to significant scale, subtle is relative. You talk about a P99 on a 10,000 requests a second, which is conservative on a lot of sites now. That P99 means you're getting rid of 1% of your users. That's 900 requests per second that you don't care about.
Yeah, and I mean, if 1% of Amazon S3 buckets became unavailable, there'd be a real problem.
Yeah. So it's becoming more and more subtle. You go up to, say, 100,000 users, 100,000 requests a second, or 1 million requests a second. That number becomes really small. And subtle could be the entire population of the UK at that point, because you are hitting quite a lot of things. It could be an entire region that's causing a problem. It could be an entire cluster of that keyword that could be causing a problem for users. And that is where having really robust observability is the thing you need now, because metrics and their aggregations and their granularities is hard. We say when we say the 99 P99s, it's not 10,000 requests a second because it's aggregated over 10 seconds. So actually, that's 100,000 requests that are lumped into one metric. That's the P99. That's a lot of requests that you don't care about. And that is where the debugging experience comes in. That's where traces come into their own. The focus for me has always been around how do we as engineers get the right data. So you don't want in that scenario you were talking about, you don't want the customer service team to send you a bug and say it feels a bit slow. What you really want is for them to go, I've got a trace ID for you. This user said it was a bit slow. And you want to load that trace ID up and you want to see everything that was happening in that system at that time. That's the holy grail. Somebody going, here's the exact stack trace of everything in every single system that thing went through. That's what we want as engineers, because then we can just fix the bug and move on and actually write some code.
This is one of the nice things about working in a developer tooling company, because my last place, obviously everyone who's using the thing is a developer, and sometimes they'd go, I had this issue, and they'd send you like their console output from the browser and sort of like their local storage or whatever, so that you had all that context.
Yeah, as a contrary to that, I work for a developer tools company. I sent them the stack trace and the screenshots of everything that didn't work when I loaded up our dashboard on the Galaxy Fold, and they went, nope, we're not supporting it. Because I mean that's the other part of the problem now. We talk about the computers that we run in the cloud. We control those computers. We know what operating system they're running on. We know what networks they're going over. Try and stick something in a browser.
Oh yeah, the client side.
Try and stick it in a mobile app. Like, how many different form factors, operating system combinations do we now need to deal with?
Well,
the answer is all of them.
Our streaming platform that we use, you try and open it in anything that's not Chrome, and it says use Chrome. It just doesn't work. Straight up doesn't work.
Chromium based.
Oh, Chromium. Okay, fine.
I'm using
That's different.
I'm using Edge. Because I'm a Microsoft guy. I have to really, don't I? It would be on brand if I didn't. But you know, that's the key now is
Wait, would you be using Internet Explorer if that were a thing nowadays?
no comment. I'm a Microsoft MVP now. I would
You
I
got to
would
watch
have
what you say.
respond in a particular way, and I don't want to lie.
I think that's why they didn't renew me after 1 year as a Microsoft MVP.
So yeah, the key now is when we are debugging those things, what we really want to know is how do we find the trace? Once we've got the trace is really easy to follow. It's a causality graph. It tells us which microservice it was part of. It tells us which endpoint was hit because, well, that's what tracing does. And tracing is really easy. We add attributes to those things that tell us where things are in that code base or what parameters they were. If we have all of that data, that's the end goal. The debugging experience, though, is how do we get to that thing? How do we get to the big roadmap of how a user's request was slow? And that is through querying data. That's the query, not a dashboard. A dashboard will display a graph. A query will allow you to build graphs progressively. And you want to be, I call it spelunking through the data and just asking questions. It's like, but what about this one? And if I slice it by this, is that? And if I slice it by that? And then I slice it by this. Oh, yeah. And what about this request? Ah, that's the one I'm looking for. And that shows me that the database query that we've got is running slow and it's this particular database query on this particular service.
Would you consider that skill analogous to the person who's able to look at the 72 dashboards and go, oh, yeah, I know what's going on?
No, I would consider this more conversational analysis. Because if you think that person does it from knowledge, what you really want to get to is a point where the person can just ask questions.
But
You want to
knowing
be
which
able
questions
to
to
say,
ask.
well, no,
'Cause
because you just go in, okay, well, this kind of looks a little bit, well, what if I slice it by that? Or what if I remove this bit of data? And you ask the observability tooling to just, well, what about removing that bit of data? Oh, no, it doesn't do anything. Right, put it back in. You know, you want to be able to have that conversation about let's add a bit of context, remove a bit of context, change a bit of context, and just graph it until you find those things. You want the problem to bubble itself up to the top so that you can see it, and then you can investigate it. And that is really where the observability vendors come in, because providing a trace view, open source tools like Jaeger can do that. If you know what trace you're going to go and look at, just use Jaeger. If you're always going to have a trace ID, just use Jaeger. It's hard to scale and all of those things, but it will give you a trace view. What you can do if you're looking at observability in general is, how do I find those things? How do I make the tool or the process so easy that you don't need Laura's help to find those problems? Like, yes, I can look at what Laura did. I can work through the query paths that she went through when she was debugging that issue, but I don't need to. I need to make it easy enough that I can just go, well, let's slice it by URL. Let's slice it by user group. Let's slice it by user agent. All of those things are just let's slice it by, or let's group it by, or let's zoom it in where this is equal to that. And if you can get to that, that's what that debugging experience should be. If somebody says the site's slow, what I want to do is I want to look at every request where the inbound route span, if you like, was over 1.5 seconds. Show me all of those. Okay, great. I can see the ones that are above that. And not just
95% of them in Norway using the French language plugin, yeah.
Yeah, and that's where you then go, all right, all of these ones, now show me what's common. Or all of these ones, let's dig in a little bit further and let's do only that, let's group by the origin, let's group by this. And then you can say, oh, it's only these ones. And the faster you can get that core analysis loop of just going and, that is what a debugging experience should look like. And really those kind of things are, from an engineering perspective, they're gold. Because I've been an engineer. I've had the bugs where somebody went, it's not working. To which I respond with, yes, it is. It's like, if you're going to give me
Work
that
on my
amount of
machine.
data, I've literally wrote that on a ticket when somebody said this particular module isn't working. I went, yes, it is, because you're going to give me no context. I'm going to give you no context. But if I can actually dig in and find some real tangible information that points me to the direction, it's not an AI robot that's going to fix your system. Observability
Not
is
yet.
not for the next couple of decades.
Weeks.
Well, I mean, I imagine that if you had a system that stayed stable long enough to get the data out and train a model on it, maybe that could be useful. But I imagine most systems that are in production are changing enough that would get out of date so fast that it wouldn't be useful.
Yeah. And if they're not changing, it means that you probably aren't going to be able to fix the bug because you won't be able to change the thing.
Yeah.
Therefore, it's pointless if you can debug it anyway.
Hey, when GPU becomes cheap as chips and you can train an AI in 5 minutes.
Yeah.
Start your week, train this week's telemetry AI.
But then you need data. You need enough normal data in order to know what normal looks like. And how much is enough data? Well, I might be able to train the model in 5 minutes, but how long am I going to be building a baseline of data that tells me what's normal? And can you tell me what normal is when we're talking about web systems? There is a boundary of
Failure,
normal.
constant failure.
Well, this is like the
That's
big
life.
danger, whenever you see these, and it's not new. I know everybody wants to talk about, oh, it's AI powered, but whatever, it's statistics. It's really just statistics to scale, right? And so this idea that we can just point the machine at a thing and have the machine give us insight is not new, right? We've been doing this for a while, okay? And in the world of observability, there have been a lot of vendors who have either come and gone or are still around, and there are new ones popping up, which are just like, we'll let the AI will figure it out for you. It will do anomaly detection. It will do, this, that, the other thing. And I really caution people against kind of relying on that blindly, especially because if the reason you're buying this tool is because stuff is wrong and you don't know why, you don't have at that point a baseline of normal to start understanding what anomalous even looks like. So if you train your model on everything's broken, then that looks perfectly normal.
I mean, the other thing is like the debugging process that Martin just described, like all of that is reasoning about what could possibly be causing this. Computers can't reason, or specifically AIs. They don't. We have this thing that's always bugs me about it is the anthropomorphization of them and treating them like they are human minds. And they're not. As you said, it's just statistics. Like ChatGPT is just what would an answer to this question look like? And that isn't useful when you actually have to do reasoning to solve a problem.
So in sort of observability, we talk about unknown unknowns, the things we don't know that we needed to know. And if we don't know that we needed to know them, how is a generative AI going to be able to work that out? Because all it knows is what you've taught it. And an unknown unknown is by definition unknown, so we cannot have taught it that thing. We can look at anomalies, but how do we teach it to have that thought process that we would have that says, maybe let's try this? It won't do that, maybe let's try this. It will go, well, we've tried this before, so we'll do this.
I mean, the fact that you use the phrase thought process there for an AI is like, they don't have that. That's not how they work. Or at least, ML models.
So are you suggesting that ChatGPT is not yet quite ready to solve like all of the epistemological, that's a funny word.
Yeah.
The epistemology? How do you pronounce this?
Epistemology.
God, English, what a language.
Epistemological.
But at the end of the day, like, we talk about that. It's examining sort of what the nature of knowledge is. What are the presuppositions? What can be valid? What is known? What can be known? What are the boundaries of knowledge? And what are the boundaries of what can be known? And then what lies outside of those boundaries, right? And obviously we could go down a big rabbit hole of talking about the nature of truth and so on and so forth. But
yeah, come back to me when an AI has come up with Gödel's incompleteness theorem on its own.
well, there you go, right?
Yeah.
But to sort of rein this back into the relevant for us as technologists, some of this stuff remains nonetheless useful to be aware of, right? These sort of basic philosophical, like we're talking first year, liberal arts degree type stuff. But this idea of there are things we can know, there are things we can't know, and then there are shades in between those two things.
Hmm.
And having a mental model for dealing with that, going like, I'm okay with the big shady part over here. Right?
Yeah.
Like I know that's there, and I am mentally equipped to deal with it, is actually super, super useful when it comes to things like debugging software or dealing with systems at scale, because it's always going to be stuff that you don't know. There's going to be stuff that you don't know, and there's going to be stuff that is literally outside the realm of what you could know. Always, right? And having a model for those perimeters is huge when you yourself are setting up your observability software, when you yourself are actually debugging these things, and knowing like that's it, like that's the limit of what I can know. I need someone else to come in and help me out.
Yeah.
Right.
And I think that there's things like ChatGPT can do for us, which is by understanding the question that we're asking, it can say, allow us to formulate the right questions to ask. If we say, well, our system's slow, well, something like ChatGPT could say, other people have done these kinds of things. Have you tried looking at this? Have you tried looking at that? And it can present some relevant information for you. That's the sort of things that we can do. We term it that we're not building an AI robot that's going to fix your system. We're building you a mecha suit. We're building you this big mech warrior type suit that you can walk around with and do things better, faster, more efficiently. That's the sort of thing that we're building. It still needs a human. It still needs some human brain that is able to reason. It's able to exclude or include data on a whim. It's able to have free will, if you like, to go and say, I'm going to go and look at this thing. It might not be anything that we've done before, but we deployed something last week, so I'm going to do this thing over here. It's able to bring in all of that stuff. That is really where I think observability excels right now, is by providing you with really fast analysis tools that you can ask questions. Now, if we can do things like layering on AI to help us ask more questions or help us ask more insightful questions of our software, and then present us with that relevant bits of information that we can take and then go, it's not just that big dashboard, that big wall of screens that has some little things like this. What it does is it shows you 4 graphs that say these are important. And you go, oh yeah, I get it now, because I've removed the noise and I've focused in on just the things that are relevant, because I've had AI assistance. The computer has crunched some numbers, because apparently computers are really good at crunching numbers. Apparently that's a thing for computers. Who knew? But it's done that thing and it said, these things are interesting. They're not the normal. It's not going to tell you service X is having problems. What it is going to say is, this is outside of the normal for service X, and you've just told me that you're looking for a particular thing. Maybe have a look at service X.
It does the first part of the guy sitting in front of the 72 dashboards who notices this, that, and that. But it doesn't do the thing of, it can't do the thing of like, oh yeah, that happened 4 years ago and I know about this. But it can present you the weird things.
Yeah. So there was a TV show a while back called Person of Interest, which I really loved as a TV show. It was this premise of a big AI that was all-knowing. And it provided, it was essentially precog type stuff. It predicted things that were going to happen, which was really dangerous. So they basically put a big firewall around the system, and all it did is say, go and have a look at this person.
You are
Like, that's
today's
all it
person of
did.
interest.
It didn't tell you what was going to go wrong. It just went, you might want to look over here. And I love that as a concept for AIs around observability, is they can tell you where to go and look, but it's not going to fix the system. It's not going to say this line of code should be after this line of code, or this line of code should have a null check. It's not going to do those kind of things, but it is going to help you get really close to where the problem is and give you some rounded context around that thing that allows you to go in and go, oh, yes, I remember John put that bit of code in last week and I've looked at the commit history and, oh yeah, I missed the unit test that did this and now I can see the edge case. And it gets you there quicker.
Oh yeah, somebody refactored code, put a comment block to the top that wasn't actually closed and commented out the entire code for the entire app or something.
I mean, that would never
I have seen that go to prod before.
But you know, those are the things that I think AI does provide. And really, that's not really AI, that's machine learning, in my opinion. It's not. It isn't well, what most people think of AI as AGI. You know, it's not really. It's just machine learned algorithms that spit out stuff on the other end. And
Yeah, what would an answer to this question look like?
exactly, and that is really useful because you know it's decomposing a lot of information. If you think about what, say, ChatGPT does right now, where it pulls in all this information from all these sources, and like you say, it says this is what an answer to that question would look like. Now, if I was to do that and I was to say, my system is slow, well, I want it to go and find all these sources of information and for it to tell me that, well, have a look at this and have a look at this and have a look at this and have a look at this. And here's some clicks for some queries for you to be able to run that will do those things. Because it's learned those things over time that other people do these sorts of queries. These are the sorts of queries that apply to your kind of model of system. You know, maybe you're using Postgres versus MySQL, so I'm going to give you queries that relate to Postgres rather than MySQL. You're using NoSQL databases in the cloud versus ones that you host yourself, so I'm going to give you queries that look like that. It's how does it help us? How does it be that bionic arm, the mecha suit that just goes, yeah, you're not going to have to go all there yourself. Yeah. I'll help you get there.
And that sometimes you know, it might malfunction slightly or give you something that's not particularly useful, but that's okay because it's not doing anything, it's just suggesting.
Yeah, human supervised.
Yeah. So considering that ChatGPT may take a while to implement this, and also considering that folks out there may not implement observability from the beginning, how should they get started? What's recommended first step?
Open telemetry. So if you remember way back, there's the term nobody gets fired for buying IBM. Nobody's going to get fired for implementing open telemetry because in most scenarios it's a no-op. It doesn't mean changing vendors. It doesn't mean removing any instrumentation that you've got. You can start on a single service. You can trace a single service. You don't have to do distribute tracing, which is involving all of the services in your organization. That's the sort of thing you can do. You can also do these things locally. So OpenTelemetry has in-memory exporters that you can run asserts against in your application. So one of the big ones, way back, a friend of mine went to a big bank. They had a big WPF application that was a client thing, that thick client thing that ended up on people's desktops. And they had a very, very slow startup that he was debugging. And what it turned out was they were generating gRPC sessions in series. They didn't open all of them in parallel. So each one of them had to respond before it got there. And he only was able to see that because he used a trace. Because the trace said, well, each of these has a parent of the previous, or each of these starts after the previous one. And you could see it really clearly on the trace graph. And that's just one service that he was doing, that one client-side thing that he was tracing. But he then threw in a test, a unit test, that when it ran this thing, it just made sure that they all started at the same time. So you can actually do these things inside your applications. That's a shameless plug for my talk at NDC last year that you can find on YouTube about how you do this in the .NET world. But that's the sort of thing that people can do now. They can implement OpenTelemetry. Nobody's going to get fired for saying, I'm going to put in some tracing inside of my application, even if it's just for me. And I send it to our existing vendor or another vendor, it doesn't really matter. But that's how people get started, because once you get started at putting OpenTelemetry in, for a start, it's very addictive. So be warned. Putting tracing in gets very, very, I could do this, and it's but it's always additive. But then you put it in your applications, you start moving any stuff that you've got from vendor specific stuff into OpenTelemetry, and it means you can start doing some really interesting things in your pipelines, and it's all progressive. You don't lose anything by doing it. There's no, I want to use this particular vendor because they're awesome at this. Oh, well, we've got to reinstall 1,500 machines with a new agent, which nobody will ever do. So, in my opinion, that's why people get started. It's got 11 different languages as part of OTel. So, if you can't find your language there, then probably think about switching language.
Or alternatively, become a contributor to open source.
Yep. But yeah, in my opinion, that's where people should start, is look at OpenTelemetry, look at tracing. Yes, you can move your metrics into it. Yes, you can start using your logs with it. Metrics are trash, logs are trash. Don't worry, just do tracing. Everything will be fine.
Cool.
We could have named the stream "Metrics are Trash."
Metrics are trash.
Yeah.
No, metrics are good. Don't be hating on metrics. Metrics have an important purpose still in many places and in many contexts, just like logs are useful and good when they are useful and good.
The problem is, you know the term when all you have is a hammer, the entire world is a nail. That's what metrics become to a lot of people. They use them where they're not supposed to be used. So metrics are really useful when you don't have context, like a CPU volumes, perfect metric. Memory volumes, perfect metric. Because there's no context for you to say, here's this HTTP request, and it's using this amount of CPU. That isn't really a useful metric. So metrics are useful like that. Logs are good when you've got something that happens at a point in time. Because we put out a thing recently from Honeycomb that traces are just fancy logs. Changed my mind. Because they are really. It's a structured log line that has a causality ID and a duration.
Bold of you to assume that the log is structured.
We've got a sticker for that, but it's got transparency on it, so I won't show it. And Eli has seen the sticker, so. But no, the idea is that logs are useful when they're a point in time, because what does a log have? Well, sometimes has a correlation ID, but it pretty much always has a timestamp. So it's a thing that happens at a point in time. So if you've got something that happens at a point in time only and doesn't have a duration, probably good for a log. So think about audit. Audit logs are a thing that is useful because they happen at a point in time. An exception is a log because it happens at a point in time. What I would say is all of those logs, though, if they're inside of your application, so application logs, they actually become what's called span events, which means they're attached to a span in your application because they happened in the context of a span that was occurring at the time. Which means that you then get your log, but you also get the full trace context that it was part of. And it's all about, well, why would you not want that data? When you talk to people about it, it's like, so you're saying that you don't want more context? And yeah, it becomes interesting when you start talking to people about that. But it's using the right thing for the right job. If you're inside of a web context, if you're inside of a messaging context, you've got context. Call it a trace. Give it a correlation ID, give them causality IDs, put a duration of how long they took on there, and what you've actually got is a span and a trace. And you can call them logs if you want, but send them in as logs. And if they've got those data, your provider is going to be able to grab them as a causality graph or just let you query them as logs. It's entirely up to you at that point. But I guarantee you, once you start getting traces and you start looking at distributed systems with traces, you will not go back, because it's so much better to have all of that context.
In honesty, you don't even need to have a complicated system. And we talk a lot about doing things at scale. We did distributed systems and whatnot, but rub a little OTel on it, right? Get started. You don't need a vendor tool necessarily. There's a lot of open source stuff that you can just Docker run it, right? Just to get started. And if you have like a single threaded application running on a machine somewhere, traces are already useful in that context, right? You don't need to be running massive distributed global systems to need traces, although of course you do need traces for that. But you can get started with traces and really simple things, really baseline applications. And if you've not done this before, Diego, to get back to your question of where do you start, that's where you start. Don't try to start with a massive, large scale global distributed system. Start with something small that you maybe wrote yourself that just runs on a Docker somewhere, or if you're feeling real fancy, you could use the K word and discover how pods and so on and so forth, how that plays into it. So this is a great conversation. We really like to keep going. We do want to be respectful of everybody's time, especially because it's Friday, and especially for me because I want to get out of here. So super big thanks to everybody who joined us on stream today. The comments, kind of on social media, everywhere. Always super love to have that feedback. The likes on the tweets always makes us feel good. So thank you for that. If you are interested in learning more about logs, I guess shameless plug, I did a whole talk about what logs are at DevFest Nantes in 2022 in English. So if you don't speak French, go check it out. It's pretty good. And another shameless plug is that we actually have some observability stuff. We have Grafana at Scaleway. It's currently in public beta. So if you are a Scaleway customer and you want to try out some Grafana, get in on that. We're always looking for more people to test it out, give us feedback. It's not Honeycomb, but it's all right. Right?
You can use Honeycomb anywhere. It will work if you've got. It will work with anybody deploying things on Scaleway, and you'll be able to visualize it through Grafana if you're using Grafana there as well as a visualization tool. So it can fit in. Don't worry. And we do offer a free tier, which is 20 million events per month, every month for free without even a credit card. So
nice. And again, definitely check it out. Honeycomb is a really cool bit of kit. So if you're a seasoned vet and you're looking for the next big thing, it's Honeycomb. If you've never done this before and you want to get your toes wet, it's still Honeycomb. Definitely go check it out. So thanks to Martin. Super appreciate you coming on stream with us to talk about observability, to teach us some things, to have talk about weird edge cases, and then join us on our little adventure as we dive into rabbit holes and then come back out again. And again, thank you to everybody who joined us on stream. Thank you, Eli, for taking the plunge and setting up all of our streaming platform and getting everybody.
We're removing Diego as a single point of failure, so
exactly.
He can have time off.
So thank you, Eli, for jumping onto that thing, which is hopefully not a grenade, but time will tell. Thank you, Diego, for coming through as always. Super appreciate it. And we will see you, I guess, next week, right?
Yep. See you.
Excellent. We'll see you on the interwebs, everybody. Goodbye.
Bye.